All right, let's try to finish up this section. Let's go to example 4. So you're going to do a few of these, a few like this, I should say. Excuse me. All right, you're going to simplify this crazy looking thing right here. Watch this. So it's the cube root of 192, a to the 5th, and b to the 10th. All right. Bless you. All right. Here we go. All right, so 192 is not a number that just pops in my head, especially with the cube root. Okay, I don't know what the cube root of 192 is, and it doesn't actually come out, I don't believe, come out to like an even number. If I put the cube root of 192 in my calculator, you're going to get some decimal. Okay, so what I would do is off to the side, take 192 and figure out what's being cubed inside of 192. Okay, and the best way to do that, at least in my mind, is to start a little factor tree going right here. So like 192. I did it one way because I didn't really cheat, but I picked numbers that work kind of easy. But like if off the top of my head, I know 2 goes into this, don't I? All right. What else goes into it? Do you remember the little trick to see if 3 goes into something? Yeah, if you add the digits, okay, 1 and 9 is 10 and 2 is 12. But listen, on 3, okay, 1 and 9 is 10 and 2 is 12. So 3 goes into 12. That means 3 goes into 192, okay? So let's put a 3 in there. So I'm going to go 192 divided by 3, and that gives me 64. So 3 times 64. You could have put 2 times whatever 192 is. I should be able to do that in my head, but I'll do it 96. So you could go 2 times 96 if you wanted to, but then you could take 96, you break that down. I kind of like the 64. I don't know, let's just see. So let's break 64 down. Remember, what do I want? I want something that's being cubed. Is anything being cubed to give you 64? Like, is 4? Yeah, 4 is, isn't it? 4 times 4 is 16, times 4 is 64. So that works. So this is 4 what? Cubed. That's what I'm looking for. Why am I looking for something that's cubed? Because I'm taking the what? The cube root of it, right? I'm taking the cube root of that number. So 3 times 4 cubed is 192, all right? And why do I like that version of it? Because of the 4 cubed, okay? And if I take the cube root of 4 cubed, what am I left with? Just a 4. Does that make sense? All right. But we still got that 3 in there, though. So that kind of causes a little trouble. But let's do this. So really, this is all under a cube root, isn't it? So how could I write this? What's the cube root of 4 cubed? Let's break this down. So this is going to be what? The cube root of 3, and then the cube root of what? 4 cubed. So that and that cancel. So I'm left with a what? A 4 and a what? Cube root of 3. Okay? Everybody with me on that? All right, so let's keep going. Let's kind of do the same thing with the a to the 5th. It's a little bit easier, actually. So what I want to do is the cube root of a to the 5th. I'll do that in a second. And then I also want to do what? The cube root of b to the 10th. Kind of what I did right here. See how I broke it down where I got a cubed out of it? What about a to the 5th? How could I rewrite this cube root so that I have an a to the 3rd? How would I write it? This would be a to the 3rd times what? A squared. Everybody see that? I'm kind of showing like every little step. There may be a point where you could do a little bit of this in your head, but it's the first time you're seeing it, so I'm showing you all the steps. Everybody good? You also have this. Don't forget this. Cube root of 3. And what about this one? The cube root of what? How do you think I'm going to write this? It's b to the 10th. So what do we got? Okay, you got a 6, but you also have b to the, what's even bigger than 6? That you can, yeah, b to the 9th. That's what I would pick, okay? I would pick b to the 9th because it's a multiple of 3, and it's the biggest one that has a multiple of 3, isn't it? You could put 6, you could put 3, but then you're going to have to do a couple other things. But b to the 9th, I think, is easy. So it's b to the 9th times what? Times b. b to the 1st. Agreed? Everybody understand what we're trying to do? Just trying to write the stuff under a cube root that has something to the third power so that we can get rid of the cube root. That's the whole purpose of what we're trying to do here. So I've already simplified this, so I'm going to keep that. Just don't forget about that. What about this? The cube root of a cubed. What's that going to give us? It's going to give us an a, isn't it? Do I have to put that in absolute value? No, because I would only put stuff in absolute value when it's... I want to make sure I say it correctly. No. Let's just write it like that, okay? Let's just write it as an A. All right, everybody see that? I could have split this up into 2, but I think you can see that. So this right there, what about this? This is going to be the cube root of what? A squared. We'll put all the stuff, see how that's got a cube root and that's got a cube root. Next step, we'll put everything under just one cube root. But for now, we'll do it like this. What's this going to be? b to the 9th, the cube root of b to the 9th. Remember what we did to that? So what times itself 3 times is going to give you b to the 9th? b cubed, okay? Right? Or you could just go 9 divided by 3, right? So that's going to give you just b cubed. Correct? And then what's this going to be? It's not just a b by itself, it's under a cube root. So we keep it under a cube root. So it looks kind of messy right now, but let's kind of combine stuff together. What about just our regular whole numbers? What do I have? I got a 4, and I got an a as well, right? And I got a b cubed. So I can put those all out in front. So I'm going to go 4a b cubed. And then I got this in a cube root, this in a cube root, and this in a cube root. So that means I can put them all under just one big cube root. So what do I have? I got a 3, I got an a squared, and I've got a b, and that is as simplified as you can make it. You're probably thinking, well, that sure looked a lot better than that. Why is that simplified? Just because we can take the cube root of stuff inside of there, and we have to do it. Even though it actually looks a little more complicated than what that is, we still consider it to be simplified. Okay? So it's kind of strange. Let's do another one. This is another example, but it's kind of the same deal. Yeah. So when you do the cube root thing, you're not going to put anything in absolute values. Okay? You're only going to do that when you have something to an even power. Remember that? Remember that little equation or formula or something that I gave you? The little theorem, right? The nth root of x to the n. It's absolute value of x if n is even, and it's just plain old x if n is odd. Since we're doing an odd root, we don't have to worry about doing any absolute value stuff. All right? On this one, we're going to. Let me get the right problem in front of me here. All right. So it's still a cube root. And let's see. So that's a cube root. And this time we have a negative. Can you have a negative inside of a cube root? Absolutely. And they throw a decimal in here. Which is kind of weird. That's all right. The 9th. z to the 7th. The only thing different about this one compared to what we just finished doing is really the negative and the decimal. So, yeah, let's do it like this. I'm trying to figure out a more efficient way to do it, but I think this is good. So what I'm going to do is I'm going to break there's like 4 different elements here, isn't there? There's a negative 0.008, there's the x squared, the y to the 9th, the z squared. I'm going to put them all under their own cube root symbol. Is that all right? Just might make it a little bit easier to deal with. All right, and then cube root of x squared. You might even be able to just do this in your head and put it here, but since I'm teaching it for the first time today, we'll just write it all down, and then the cube root of z squared. All right. So what's this going to be? 0.008. Well, you know the cube root of 8, right? What's the cube root of 8? It's 2. So there's probably going to be a 2 in there. But what's your, what I would do, tell you the truth, is put it in a calculator, right? Let's just see what we get. Do you know how to do cube root in a calculator? 0.008, cube root. I hit second function. I got 0.2. But it is negative, all right? And you keep it negative. So this is just negative 0.2. Because if I go 0.2 times 0.2 times 0.2, what am I going to get? I'm going to get 0.008. Everybody good? Some of you guys are sleeping way too early. Usually lasts longer than that. All right, look at this. Let's do the x. Cube root of x squared. Can I simplify that? Can I make that x squared into something that's being cubed? No. So I'm going to keep that right where it is. Let's do the ones where I can simplify. I can simplify this, can't I? We just did it in the last problem. So what is the cube root of y to the 9th? It's y what? It's y cubed, isn't it? Everybody see that? Did I miss something? Hold on, let me see something. Oh, no wonder. That was dumb. That's not a 2. This is a 7. Sorry about that. So this is z to the 7th. All right. Tell you what, let's break that down. Let's just do it right here. All right, because we know it's the cube root of z to the 7th. Can I break that down so I have something that you can take the cube root of? Yeah, let's make it z to the what? To the 6, right? Would you agree? Times what? Times is z. All right. So let's just write everything down. That's the cube root of x squared. What is that? That's just what? Oh, I already put it there. There's your y squared. Okay, I already got that there. So I took care of that, took care of that, took care of that. And what's this going to be? The cube root of z to the 6. What's that? Z squared. And then you still got a cube root of this z. So I'm going to write cube root of z. See what we're doing? See, I took that, made it into this. Then I took the cube root of z, and I just put it right here. So now, we're kind of done. We just got to make it look a little prettier than what it looks right now. So let's put all the whole numbers, the stuff that's not in a cube root, let's just put it all to the outside, to the left. So I've got a negative 0.2. I've got a y cubed. I've got a z squared. And now these two things, right here and right here, are both under a cube root. So put the cube right here. And what do I get here? X squared and what else? Z. And that is how you write the answer. It's kind of ugly. It's not pretty. But that's what they want you to do. Does that make any sense? All right. Let's do another one. We've got a couple more like this. So this is part B. So this is the square root this time. So this has the potential to have some numbers that are in absolute value. Remember that? All right, so let's make sure we think about that when we do these. So you got 320, you've got an x squared, you've got a y cubed, and you've got a z to the fourth. Now this time, this is not a cube root. This is a square root, okay? Keep that in mind. So I want to write 320 with something that's squared. Now, is there anything squared that actually equals 320? No, there's not. All right, so what I'm going to do is I'm going to come over here. It does end in a 0, so what could I put? 32 times 10. Does that look good? Let's take 32, break that down. You break down a bunch of different things. I picked 8 times 4. I don't know why. Just try to split the middle a little bit. Could have gone 16 times 2, right? And then broke that down. It doesn't matter. Still, you'll still end up with the same thing. And what's 10? It's 2 times 5, isn't it? 2 and 5. Again, what do I want to do? I want to write this so I have something that's squared. Okay, what squared is this going to be? Go ahead. Yeah, I just didn't know off the top of my head 64 and 5. But yeah, that would have been perfect. But did that just pop in your head, 64 times 5? It did? All right, well, you're a better man than I am because I wouldn't have thought of that. I saw this ends in a 0, and for me, the easiest way for me is just making it a 10. But yeah, sure, you could go 64 times 5. That would have been perfect, okay? But what about this? What do we got here? There's 8 times 4 is 32, times 2 is 64. So I can write this, what? This is a 64. I'll tell you what, let's write the number down. So that's 64 times 5. So we eventually got to that, okay? But what squared gives you 64? 8 squared. So that's 8 squared times 5. Agreed? All right. So that's what this is going to be. So we've got a square root of 8 squared and then times a 5. So all that to get this part right here. Everybody understand why we got the 8 squared? Because I'm going to take the square root of something squared. So that's going to get rid of that 8 squared. Okay? Make sense? All right. What about the rest of it? So I'm going to have the square root of x squared. I'm going to have the square root. Let's think in our head a little bit. What am I going to write for this? What's that? It's a nurse. You sick? You can't wait. Hurry up. Write a pass. You got to write a pass. How am I going to write this? Y squared times y. Good. And then what's this going to be? Well, I'll just write it in here. Okay, we'll do that in the next step. Okay? Everybody with me so far? All right, let's do this. The square root of 8 squared. What is the square root of 8 squared? It's just 8. And then this is going to be the square root of 5. What's this going to be? It's going to be an x, but remember that little theorem thing that we did yesterday? If you have the square root of x squared, this x cannot be negative, so it's got to be what? Absolute value of x. Remember that? Yeah, we talked about that yesterday. Just take a look at that. There you go. What about this? Again, we got the same kind of thing, right? The absolute, or the square root of y squared is y, but it's in absolute value. And then right here, we got a square root of y. Correct? Yeah. Let me see something. All right. What's this going to be? Square root of z to the fourth. Z squared. Now, do we have to put that in absolute value? No, because it doesn't matter if z is negative or not, because when we square, it's going to be positive. So we don't have to put that in absolute value. So that was all the work. Now it's just cleanup. All right. We just make it look kind of pretty now. So I would go 8 first. Let's just do our regular whole numbers, not the stuff inside square roots, okay? What else do we have that's nice and pretty? That z squared probably, right? Or it doesn't matter. The book, I'll do it the way the book does it, okay? They do the x and the y first, but since they're being multiplied together, I'm just going to put it under that one absolute value, or put it inside that one absolute value like that. Everybody see that? So I'm done with this one, done with this, done with this. Now I can go ahead and put that z there. They probably wanted it like that just to put it in order, x, y, z. All right, it wouldn't matter. You could have put the z first if you wanted to, the z squared first. All right, so I'm done with that one. And what do I got? I got 2 square roots, so it's the square root of what? Just 5y, and that's it. Okay, that is that simplified. Just can't break it down anymore, okay? It doesn't mean it looks a lot easier. It doesn't mean it's less writing when it says simplify. It just means I can't break it down any further than that. So that's what they mean by simplifying it. So kind of strange, but it's not that bad. Let's do another one. This is part C, and we're going to go 4th root this time. So we did a 3rd root, did a square root, now we're doing a 4th root of 32, x to the 5th, y to the 7th. All right, let's take 32 and think about that. There's a couple things that are 32, but this one's kind of easy. It's a smaller number. Okay, there's definitely something that pops in my head. Remember, we're trying to find something to the 4th power, to the 4th. So what do you got? How about 16 times 2? Is that one of the first things? Yeah, I picked 16 times 2 this time because I didn't do 8 times 4 because I know something about 16. What is 16? 2 to the what? 2 to the 4th. Okay, times what? A 2. If you wanted, you could have broken it down into its primes if you wanted to. All right, so what would that give you? Like 5 of these, right? 3, 4, 5. So what are you trying to do? You're trying to group them into groups of 4, right? So there's your 2 to the 4th, and there's your 2. So if it comes down to you're not really sure what to do, break it down as far as you can, and then group them into 4s. In this case, if it was cubed or cube root, then you break them down into little clumps of 3s. Make sense? All right. So let's write that down. So what do we got? We got the 4th root of 2 to the 4th times 2. We'll simplify that in the next step. What else we got? X to the 5th. So this is the 4th root. Let's break that down and just put it right here. So how are we going to break that down? We're going to make it x to the 4th times x to the 1st. Okay? Let's do the y to the 7th. Again, it's the 4th root. So I'm going to break it down into groups of 4. So what do I get? Y to the 4th. What's left over then? Y to the 3rd. You got it? I should make my own app. It's like, fall asleep to Mr. Hamrick, the soothing tones of the boring math class. It'll put you right to sleep. I think I might be onto something because it's working. It's working in here, man. All right. So what do we got here? 4th root of 2 to the 4th. What's that going to give you? It's going to give you just a 2, isn't it? You see that? Because that 4th root cancels out that 4th power, and I'm just left with a 2. What do we do here? Well, that's a 4th root of 2. Okay. What about here? 4th root of x to the 4th. What's that going to give you? It's going to give you x, but remember, that has to be an absolute value. Why didn't we put that 2 in absolute value? Because 2 is 2, right? It's not negative. It's just 2, so I don't have to put it in absolute value, all right? But this could be, right? This could change. This could be negative or positive. I only want the positive version of it. Because if it was the negative version of it, wouldn't work. All right, what about this? 4th root of x. What about this? 4th root of y to the 4th. That's a y, but it's also absolute value. What about this? 4th root of y cubed. Can't break it down. So that was all the work. What do we do now? Just clean it up, right? Make it look pretty. So what's the first number you're going to put? Probably the 2. Yep. All right, so we're done with that one. I'll leave the roots to the end. All right, so what else we got? Just the x and the y, right? So I've got absolute value of x, y. And now let's do the root. So it's the fourth root of, what do we got? 2x and y cubed. So 2x, y cubed. And there you go. That's it. Yep. All right. Enough of that. Let's do something different. Let's do that thing you're asking about in the homework. Okay, it's called Heron's formula. Not Aaron, me. It's not my formula. I didn't come up with it. Heron, Heron. I was going to look up this person, Heron. I'm sure it's named after a person. I could not tell you one thing. I don't even know if it's a guy. I don't know anything about this. I was going to look it up. I just got lazy and I didn't do it. So here's what it says. It says the area of a triangle. This is any triangle. It could be a right triangle, could be an obtuse, could be an acute. So this is kind of interesting. The area of a triangle with sides A, B, and C, with sides A, B, and C. Let's do this. Is equal to, you ready? Yeah, we did this in geometry. So it's S. Now, we got to talk about the S in a minute, okay, what the S represents, okay? I could have done it first, but I'm going to do it like this. So S minus A, S minus B, and S minus C. But what is the S? What is that S? The S is called the semi-perimeter. What do you think it means? Like if I had a semi-circle or a semicircle, half of one, right? So what's the perimeter of a triangle? If the sides are A, B, and C, what's the perimeter of a triangle? Yeah, A plus B plus C. But this is the semi-perimeter, so what is it? Over 2, right? So S is equal to this. Does that make sense? Right? They don't even attempt to show you how they got that. A lot of times they do when they give you a formula like that. They'll go through some stuff and they'll say, oh, this is how we came up with this formula. They didn't even try to do that here. So again, I'm not super familiar with this formula myself. I guess I could have looked it up. But those two things right there are pretty important. Like this one right here, you didn't really have to memorize the semi-perimeter, okay? Semi-anything is half of it, all right? Semicircle, half of a circle. So this is the perimeter divided by 2. That's what the S is, all right? That's half of the perimeter. That's half the perimeter. So is that, so is that. And this is square root and then S times S minus A. And these are all the sides of your triangle, A, B, and C. All right? I don't expect you to have remembered that formula, but it should make sense to you now. Would you agree? Yeah, it's not that difficult to understand. It may be, and my guess is, it's probably kind of hard to come up with it because they didn't even attempt to do that for you. So here's your problem, and we will be finished. And they make it look like this. Oh. This is still 7-1. And they tell you that this side is 45. They put it in yards, but we'll just put the yards in at the very end. Is that all right? All right. What do you think they're going to ask you to do to this? Find the area, okay? Look, if you had to find the area of this traditionally, how would you find the area of a triangle? 1/2 the base times the height. The problem is, with this information that he gave you right there, that might be pretty tough to find this height. Wouldn't you agree? Okay? So they don't give you the height. And, I mean, you might be able to do it. Maybe. I don't know. Yeah, you might be able to do it. Well, you might have to use law of sines to find an angle, find this angle. You haven't even learned the law of sines yet, so yeah, there's no way that you could do this, okay, by 1/2 the base times the height at this point in your math career, all right? Later on this chapter, no, not this chapter, if we ever, I don't know if we'll get to trig or not. I'm thinking, did I tell you that yesterday? I'm thinking about maybe cutting this chapter short just to make sure we get to some trig. So we may do that. So this might be the last week we do this radical stuff. not that it's not important. I just definitely want you to do some more trig so you're ready for next year. All right. So let's find the area. So it's just a matter of just throwing stuff in a formula. Really not that hard, but you got to know the formula though. That's the problem. All right. So equals S. That's what I'm going to do first. Let's find the S. How do I find that? Add them all up. Add up the sides. 54 plus 81. And then I divide that by 2. And the top actually is 180. Has nothing to do with 180 degrees in a triangle, okay? It's just the length of the sides. So it's 180 divided by 2. So S is what? 90. Again, it's not a degree, all right? It's just the semi-perimeter. All right, and now we're ready to put it into the formula. Let's put it right here. So we go S, which is 90, and then we go S minus A. It doesn't matter which one you call A or B. Let's just go in this order right there. Is that all right? So 90 minus 45 times 90 minus 54 times 90 minus 81. All right? And you just chuck all that into a calculator. Let's just make it a little easier for us. So that's a 90. What's 90 minus 45? 45. 90 minus 54 is 36. And then 90 minus 81 is 9. All right? So that makes it a little bit easier to put into your calculator, right? Chuck them all in there. Multiply them all together. Take the square root, and you get 1145.5. What did I say this was in? There yards. So this is area. So it's what? It's yards squared. And there you go. That's how you do it. It's not easy to, it's not hard to use. You just have to know what to put in, and what formula to use to put the stuff in there. Okay? All right. What did I tell you yesterday about homework? Did I say just do as many as you could or something? Or what did I say? Did I assign it? I told you could do it? Okay. All right. Well, here it is. It's official now. All right. So that's, what is it? 7-1? Yep, first lesson. All right, so section 7-1. I should write that down. 1 to 41 odds. Okay, it's just the odds. It's only, 20 problems, something like that. All right, so only. Yeah. Well, you could have started yesterday, right? You could have done a few of those. Say what? Oh, you finished it already? All right, well, there you go. Good. So there might be a couple, did you do that one? Okay, well. There wasn't one like that. There wasn't? No, that's like stopped. Oh, really? Yeah, it's just 42. Daggone it. Yeah. Well, anyway. This was probably more helpful that we did this today, right? Yeah. So were there problems like this? Okay. Yeah, well, there you go. Usually people don't complain if they've already got it done. And I assign the same, thing. But now you can go back on it. If the ones that you struggled with, you weren't really sure what you were doing, you can go back and try them again, okay? So doing your homework, it's not a punishment, okay? It really is not. I'm not trying to punish you. I'm not trying to give you busy work, okay? That's not what this is. It's not busy work, okay? This is where you learn, okay? Watching me, it's helpful, I think, to pay attention and watch how we do it. But you're not going to learn by just sitting there watching me, all right? You've got to do it yourself. It's the only way that you're going to get good at these, all right? So that's why I give you the homework. Isn't that nice of me? All right, so that you become good at it, and that helps you out. All right, so make sure that you get those done, and make sure that you're really trying them. I would probably say out of all my classes, this is probably the one class that probably tries on their homework better than all my other classes. All right, even my pre-calc class, I see some people just scribbling stuff down, and I just know that they're really not trying. But I would say almost everybody in here, when I look at your homeworks, for the most part, it looks like you're really, really trying to get them right, and that's good. Keep it up. Don't stop doing that, okay? Because that's really going to help you. All right, any other questions, comments, anything?